In previous QueXs episode about BC660K-GL module, I promised to publish a demo on DRX, eDRX and PSM modes, and here it is. Hello friends, this is new episode of QueXs and I'm your host, Dmitry Yermolin. And as always, I'd like to remind you that QueXs are in-depth technical videos about Quectel products. So here on YouTube you can get the latest news on Quectel modules and antennas, and that's not all. We are also going to do many tests, explore module modes and features, and have fun with module programming. Moreover, after each episode there will be QueXs Masterclass webinar with topics related to the video, which will go into more details, and there will be Q&A session as well. Now let's refresh in memory what DRX, eDRX and PSM modes are. I intentionally will use very sketchy diagrams to illustrate the explanation. The reason is that for different networks and different modules, the exact values and sequences may vary, and later it may bring a lot of confusion. So, how it works? Normally, a device, after starting up, searching, connecting to NB-IoT network, and transmitting data, switches into idle mode. In idle mode, a device can be reached by network and receive some data using discontinuous reception, or DRX, also known as the paging cycles. DRX cycles normally is pretty short, for example, 2.56 seconds, and it is defined by LTE network specification. In other words, a module wakes up for the short time at the beginning of every DRX cycle to listen if there is any incoming data transmission. It allows to save some power, but not too much. If application doesn't need to receive data that often, we can use eDRX mode. eDRX stands for Extended Discontinuous Reception. It allows to add sleep periods between the series of DRX cycles and reduce power consumption in idle mode. In both DRX and eDRX mode, a module is still on and running but consumes the lowest possible current. PSM is a little different thing. Enabling power saving mode, we can sync with the network values for two timers. First is the active timer, which defines the paging cycle duration. Second is the extended timer, or periodic tracking area update timer, and it defines the total duration for the paging cycle plus power saving mode cycle. In other words, we book the communication time frame on the base station and completely switch off the module, leaving only wake-up timer to work. So, after active timer expires, module stops DRX cycles and network stops communication requests to the module until extended timer will expire. And extended timer value could be set as long as you need for your application, as LTE network approves. After extended timer expires, the module wakes up, connects to the network again, sends data, performs tracking area update procedure, then switches to idle mode, and then PSM cycle may repeat. PSM offers the lowest power consumption, and it is a good mode for applications that only need to transmit data and don't have to stay reachable for the most of the time, like some meters, for example. Now let's see how it looks practically and what values BC660K-GL can achieve. Here we have a record made in the lab by my colleague to illustrate all these modes. Let's analyze it step by step. Now the module is configured in the way that allows us to get reports of unsolicited result code, and we will keep being reported after the module reset. Another important note is that PSM and eDRX modes are already on. We reset the module and it reports exit deep sleep. Now we see module reports that it is ready for work. Then it returns user equipment functionality. Value 1 means that user equipment is in full functionality. If it is necessary to enter SIM card PIN or SIM card pack, cpin read command will return the corresponding value. Status ready indicates that no further entry is required. CREG shows the network registration status. Value 2 indicates that the mobile terminal isn't registered yet, but it is searching for the operator to register to. CCON read command gives us the module signaling status. Now it shows that the module is connected. In the next second, we see the module returns its IP address and updates the network registration status. Now it says it's already registered and the network showing value 1 instead of 2. Here we can see that after around 20 seconds in the connected mode, the module switched into idle mode and then, as PSM mode is on, into PSM mode. We see corresponding report updates in QCOM utility. We can write down the average current and power consumption value for the connected mode to compare it later with the values in other modes. Here we frame idle mode and we see in QCOM utility log when the module has disconnected from the network. Now we can measure the module power consumption in PSM mode. Measurement duration is around 5 minutes. Here we also can fix the measured values. We disable PSM mode and get the corresponding report log update in QCOM utility. Now we can measure the power consumption in eDRX mode. This is tau process triggered by disabling PSM mode. Here we measure power consumption during the eDRX cycle. Let's fix the values. And here we disable eDRX mode. After disabling eDRX, the module connects again and then goes into idle mode. Here we read eDRX dynamic parameters to ensure eDRX is off, and ID command execution will affect the graph, but we will exclude this part from the measurements. Finally, after disabling both PSM and eDRX, we can write down the values for DRX mode. We can return and double-check all the values. And here is the resulting table. As was expected, the lowest power consumption is in PSM mode, then in eDRX, and the highest one is in DRX mode. We could expect such a distribution, but look at the absolute values. They are incredibly low. It is hundreds of microamperes for DRX mode, tens in eDRX, and hundreds of nanoamperes in PSM. Just imagine applications you could build with BC660K considering such a lower power consumption. This is different level of IT device autonomy. If you want to test all these power-saving modes on the BC660K-GL module by yourself, you will need the evaluation or developer kit, which you can order by the link in the description under this video. In the next episode of QueXs, I'm going to make a detailed review of this kit and show how to connect it to the PC and start with basic operations. And not to miss this new episode, subscribe to our channel and don't forget to hit notification bell. Thanks for watching QueXs, and let's build a smarter world together.